Hello everyone, here we are again. Today I will deal with repairing a university network that a friend has sent me. The repair will be mainly for educational purposes. To generally see the mindset of a repair, the measurements that can be taken, and generally the steps we need to follow. So sit back, turn up the volume, and let's get started. First of all, we need to identify the board, the thing we are holding. Here we see the screen of it, and on the board, let's start from the beginning. Here is the AC output that goes to the network above. I should mention that the university network takes input from a panel and provides our network with 220 volts. Here the panels are installed, here the DC input is required. Interactivity increases the displayed voltage. It is from the panels at 220 volts. It creates the same phase and feeds it back into the network. So here are the redesigners. They are power supplies which take the panels 40, 50, 60 volts they provide and boost them to 220 volts. They rectify them, smooth them out, and then with some other MOSFETs they create the inverter, bring it in phase with the network, and feed it back. Here we find the order of the MOSFETs that actually increase the voltage. They consult with the redesigners to operate to bring the 220 volts. And here at the end, we have a series of MOSFETs and thyristors, which create the half wave, regulate it, and feed it back into the network. Here, the penalties over there next to it are filters, and they go out to the network. And all of these need, of course, a controller to operate, which will also be an oscillator that will be an elector controlling the MOSFETs, and is located right here, and which is powered by this cable over from a second power supply that has a small one next to it. And here, basically missing is a regulator at 3.3 volts, which is one of the capacitors which have been removed, I don't know why, and right next to it is the controller. Let's take a look at it from below. Down as it is, we see here, outside the rectifiers, two thin ones in reality, and have changed here some MOSFET and some thyristor. They have replaced them, I see here, not with great success, because we see here that they are in the air. You see here they have also gone from above. Meanwhile, the board is double-sided, and they follow up and down. Even where there is a track, you see here the little leg moves, so it has not stuck from above, and there is no track missing from below, so it's in the air, as if it has not entered at all from above. Like this. We must be careful when putting on and taking off components on a double-sided board to stick both on top and bottom, and when we remove them to try as much as possible not to damage the tracks. Or when we solder the pistons, or if the pistons burn, in the end we should connect them to the bottom side of the board. And here we see some missing cartonotala. I don't know if they are missing or if it's just the holes over here. They might not be missing. Anyway, an attempt has been made to repair this board, and here below is the power supply, as I was telling you, which operates the controller, and the second power supply it has for the controller. As I was saying, an attempt has been made for repair. The damage, the initial one, is that a fuse blew. It didn't trip at the socket, but a fuse blew. That was its problem, in other words. All right, its output was circling. So I conclude that somewhere in the MOSFET and the thyristors, I have my issue, my problem, the beginning. Let's see what else I can visually inspect. I will zoom in a bit over here to visually inspect it at this point. What else could be there? What could have happened? Well, we see here, besides the MOSFET that we mentioned was replaced, but in reality it's resoldered in the air though. It's not even soldered like this. We see here the legs we mentioned. They are detached both from the top and the bottom. Here above, we see a resistor that appears burnt. You can see this point looks burnt, so most likely both the MOSFETs and the thyristors here have an issue. This resistor supplies power to the thyristors, which in turn power the MOSFETs. so I won't take any measurements on the board right now as we are. So I need to remove the MOSFETs and the thyristors to fix the traces, and then continue. I will measure them, that is, off the board, with my hands after I remove them, and if they are good, I will put them back or replace them. Okay, I removed them from the top. Well, let's see what they are first. I should mention that I don't have a manual, I don't have data sheets, so I do everything empirically. The first MOSFET says 33N25 on it. It means it can handle 33A 250 volts. It's a bit suspicious for an output MOSFET. We'll see how it goes later. The 250 seems like a low voltage to me, you might say. And the triac, the thyristor in my opinion, is the S8008. Let's measure now to see if they are correct. I have shown in a previous video how we measure the thyristors and MOSFETs. Well, okay, I will measure the thyristor now. I will see if it has any protection circuit to start with, nothing else. To check it, I have to make a little circuit to test the beast. So empirically, I look at the two expensive little feet if they have a small resistance and the rest have none at all. Then the beast is good, usually. When it burns, it short-circuits all the feet together. We see here that this beast looks good now. Let's move on to the MOSFET to see what's going on. I measure here and see that I have a short circuit in the MOSFET. The MOSFET should not short-circuit any 2 feet together. We should find a diode between 2 feet, like a diode, and the rest should be open. So this specific one is burnt. It is short-circuited. Therefore, I will replace it. I will make the tracks, put the same beast, and replace the MOSFET with another one. I will also remove the other MOSFET from the other side to check it for sure and continue. Well, here we have it. I will measure it in the same way. I will check and let's find a diode on the 2 little feet, and the rest if I trigger it to be from the diode over here. And logically, if I trigger it with plus or minus, it should nullify this 302 it shows. Here we see that it does not nullify. While it seems good, it does not short-circuit the MOSFET. It does not trigger, so it's burnt. I will measure now and show. The one I showed you before that seemed burnt, I will make sure it's burnt. You see, it is an ohm meter parenthesis office. It does not show anything. So this one is also burnt. We will replace it. And I will measure. There are also some resistors you see here at the gate of the MOSFET, which usually if the MOSFETs burn, they short circuit, these resistors also get damaged. There are some SMDs down here. I will measure them. They are for these. These show around 10 ohms from what I see. I see here, we measure, and nothing. It is also burnt. The gate resistors are burnt as well, and I don't know if the driver below is burnt too, leading them, because it has probably passed voltage from the gate. It doesn't have any resistors, and I don't know if the driver or an integrated circuit that I see here is burnt. The other one is burnt from what we see here. It shows 99 kilos, so the other one is definitely burnt too. Look here, it shows 99 kilos, meaning from the 10 ohms you see to the 90 kilos. It's a big difference. I will remove them, replace them as well. So what do I do now here? I said I will replace the 2 MOSFETs. I will fix the tracks. I will change the burnt resistors we found. And I will try to see if there is a problem with the rectifier or something else. If you see it, the problem continues. So what do I observe now? That this MOSFET is 20N60. meaning it can withstand 600 volts at 20 amps. This is a MOSFET for output. That is, it seems better for MOSFET output. So the other one is probably the same. I had simply replaced it with a 33N25, and the triac is the BT152, which is indeed equivalent to the S8008. However, the 33N25 is not equivalent. Why, there are indeed many amperes, but the 250 volts are low for output. That is, they are fine. So I will put 20N60 in both. I will now show you the measurements. We compare the measurements of the two MOSFETs we removed, the burnt ones and the good one, which is the third, the 20N60. So we will go to the first MOSFET. We measure until we find a diode. In the first MOSFET, we have the diode you see here, and you need to trigger it with either a plus or a minus to zero this value. I have shown this in a previous video. If you refer back to my video, you can see the measurement I'm taking on the beast. You see, this one is not triggering, so it is burnt. First, the second MOSFET, we show it there, we measure it, and we show that everywhere, you see, everywhere it is short-circuited. So this one is also damaged. And now we will see the good. How should he behave? Look here. We said we are looking to find the diode. Here is the diode. And with the plus, we trigger it, zero it, you see. We put the minus, we trigger it, and it returns. With plus, it zeros. With minus, it returns. And it can return with the hand. With the ground, it nullifies. And if we short-circuit the legs with the finger, look. It brings back, you see. So this is correct, because it's already triggered. This is how we check the MOSFETs. And let's go see a bit the beasties. The SCI S808. So the two extreme legs will show a small resistance, and the rest nothing. That's their logic. You see here the two extremes show a short circuit. In the ohm meter, if I put it on resistance, I will see it. I can show you in half a minute. I will put it on ohms. The two extremes should show around 1/3 150 ohms. Ohms, like this, and the rest of the legs, nothing on the ohm meter. There we are not 100% sure that the tester is working. We see that it is definitely not short-circuited. If we make the little circuit that I showed you in a previous video, we can check, see for sure that it works, that it actually does the card. But usually the MOSFETs, the thyristors, when they burn, short-circuit the legs among them. So I made tracks, bridged the lines that have been cut, changed the MOSFETs, put the thyristors in, and let's go for a test. Let's see if there is another problem. So what are we going to do? If I plug it in now, as he said, it will blow a small 2A fuse. And there is a problem with the oil heater. The fuses will blow again, because it will give them a pulse. They will remain open, and the fuses will blow again. You see here the regulator I have installed. This is how I have installed both this and the missing optocapacitor. In order to prevent the fuses from blowing again, I will install a bulb, you see, around 60 to 100 watts, in series with the socket, with the electricity, that is, with the phase. I will connect a bulb around 100 watts, 220 volt, in series with the phase, and I will plug it into the socket. Will the lamp work as a fuse, so if we have another short circuit below, the lamp will remain lit and not burn out? This is a trick we usually do with pulse transformers. If we couldn't take measurements, we can't take subordination measurements. Because I also depend directly on the components. If we put it in a stream, my components start. This way they protect the components, but the Inverter does not start. The lamp remains lit and starts flickering. Trying to start and stops, cuts off, so we have another problem. If I had connected it bare now without a bulb, it would have burned the MOSFETs again. I'm sure of that. We have another problem, and the problem will either be in the oscillator or in this integrated circuit you see here, which controls the MOSFETs. This integrated circuit, from what I saw, functions as a switch and pulse inversion. So either this has a problem or neither does the oscillator, which is the large integrated controller next to it. I will first check the controller to see if it is working correctly. Here it is. You see here in the socket, I have provided my power supply, separate voltage of 12 volt. Since I cannot plug it in to start normally, I will provide it externally with my power supply. I have found where it goes to the simpling regulator, the 12 volts, and I will provide them directly here to measure, to see if they go to the correct voltage in the controller. It also has an indicator light next to it, which is not turning on. It should normally light up if the controller is working. So I suspect that the problem lies here. So I have connected my power supply. I have provided the 12 volt. Let me measure to see if the regulator is working first and if the controller is receiving voltage. I'll put insulation here. The regulator is over here. The common ground I have solved. After the input, I have 12 volt provided by the power supply. At the output of the regulator, I have 3 volts. So the regulator is working fine, and the voltage goes to the controller here. The 3 volt you see here. So logically, now the indicator light should light up and show me values outside, as I am with voltage only. So I saw from the controller's database. And the other observation I make is that I see on my power supply, it draws 600 milliamp, and the integrated circuit heats up. So another indication that the controller is burnt. My nice power supply is drawing, and the integrated circuit is heating up. The other thing I can do is to remove the controller and see if my power supply stops drawing these 600 milliamps. It seems like a lot for the integrated circuit to do nothing on its own. So I remove the integrated circuit and will measure now to see. I apply voltage. I see that the power supply is not drawing anything, 0 mA8. I see that the power supply is not drawing anything, 0 milliamps. So the only thing working is obviously the regulator, which must also output 3 volts, yes? And it has short-circuited in reality because the 600 milliamps is like a short circuit. It sees it. It's a lot for an integrated circuit on its own. So the controller has burned out. And here is where I will stop my video. I can't continue. I need to search to find the specific integrated circuit. It is programmable, so I have to find it from the company. If I find the company in China, after all, I will try to find it, and I will continue the video if I find it and how I find it. So be tuned into my channel if the second video comes out to watch it. Well, if you liked the video, give it a like. I'm waiting for your comments, and I believe I did not tire you. Hello to everyone.